All right, hey again. I'm gonna again try to make this quick, but we'll see. The other thing, I'll sort of tell you what I'm gonna put in here, and then you can kind of skip through, or you can even play this on super fast speed just to see if there's anything in here that you might want. But what I thought I would do is, so first of all, actually just going back to this, so keep in mind, this is written here as kind of like the planning section, but remember that many of you have data. You can start on your processing, making your graph, and then even doing your conclusion, your evaluation. But again, remember what you turn in today. So, and you don't even have to turn this in, but I would put an assignment up here, and I think some of you have done that. I know at least one person has done it. So at least I can kind of see what you have, and feel free to comment in there if you're not quite sure. And some people did this too, emailed me and said, hey, I'm not quite sure what's supposed to be in this section. So again, I'm not there to help people. So, just try to kind of put some stuff in the layout of the report. And then if you need to go back to some of this stuff next week, which I imagine that you will. So actually, I think on Tuesday we don't have class. I think there's an assembly. So this is something that you can kind of be working on. But if you need help making your graph, or if you need help, getting the data from LoggerPro and putting it into a graph. But what I thought I would do today is just to help. So, again, you can kind of be working on the setup, really describing what you did. So yeah, for somebody to repeat the exact same procedure, what are all the details that they need to know? But then you should also, similar to the dynamometer lab, include at least, one trial, and it could be all of your data too, and explain how you collected the data. So then what I thought I would do here is, right, kind of show you this. So this could be, and I actually found this old data that I had collected about changing hydrogen peroxide percentages, concentrations, and then looking at different rates of reaction. So in your methodology or your methods, whatever you call them, procedure, you want to explain, so I could show this and say, look, I noticed that you have this initial rate, and the rate drops off as some of the substrate in that reaction is used up. And so you want to explain, what slope did you measure? And so I could make, I could explain that I'm going to measure the slope for the first part of the graph until it noticeably changes. And so one of the things that I wanted to show you was also how to put the uncertainty of your slope, but then also how to look at the uncertainty of the repeated measurements. So that's what I thought I might do here. And so also, if you have a bunch of lines on here, one thing that I normally do is go to, well, you can kind of see in here, if you go to data set options, you can, oh, sorry, you got to select one of those. But, sometimes these come up as like latest, I forget what they call them, like trial one or run one, whatever. You can go in here and you can change the name. So I labeled these so that I would know what was what. And I know that some people kind of kept track of, oh, I always did this one first. But the other thing that you can do here is you can say, like, I'm going to hide, for the screenshot of my data, I'm going to hide everything except for maybe my 5%. So I could just kind of start hiding these, and then these will disappear. And I might want to just show one. Okay, so let's see. I don't know if there's a way to do this faster, but, and then you can do show data sets, right? I want to put some more up there. All right, well, that seems good enough for now. Okay, so here's where I might say, so let's look at, so I'm going to try to select this point of the graph until, like, where does this start to change? So I just want this initial rate. So kind of this, maybe the first 20 seconds here. And I'm going to look for my slope, and let's just do the 5% to see. All right, so I'm going to just change one of these so that you guys can see it. All right, so normally, again, uncertainty, you're going to make the call on what the uncertainty is. And a lot of times on LoggerPro, so, I've selected this range. You can move these brackets and you can actually see how the slope changes. And what you're looking for is so in this slope, which digit is uncertain? And remember that we actually want to list that uncertain digit. So as I'm looking at this, I'm thinking, okay, it's 0.02101, right? But now I'm going to look and I'm going to say like, okay, as I move this, the 2-1 is well, except it changes a little bit. Like, so I'm going to write this as, so whatever I choose for my range, right? I think the 0.021 are pretty certain, and then that last digit is uncertain. So first of all, I'm not even going to write the 2, but like I also kind of want to look for by how much does this change? And so I'm looking at, it's pretty close to 0.021. So you kind of have to make a call here of how, of what that uncertainty is. So I would say it changes by about, I don't know, 0.0005 or something. But you might want to try this with a couple other ones too. And I know you guys can't see this, but so this one is, yeah. So here's where your data table, and I'm actually going to show you guys this. So this is a really common arrangement if you, like, let's say that you have 5 values of your independent variable. And then, again, if this were your independent investigation, you were doing this for 10 hours, you'd probably want to have 5 trials so that you could calculate a standard deviation. But for our lab, right, so this is your, independent variable. So here, let's say this is my hydrogen peroxide concentration in percent, that's my unit. And then my dependent variable was like rate of oxygen production measured as, well, and I could even say change in, rate of pressure change. And my slope, you can even see it here, is kilopascals per second. Kilopascals per second. But then I want to say, and you can do plus or minus. So 0. I think I'm going to say it's this. So I think, what I'm going to list here, I'm going to list to that decimal place. And then I'm going to say that that is uncertain based on looking at some of these and seeing by how much they change. And so this is something where, write something in there now, but if this doesn't quite make sense, we can talk about this a little bit next week. But the idea here is how uncertain is our measurement. But then, most people had at least 2 trials. I'm not sure if anyone got to a trial 3. I don't think anyone got to a trial 4. And then this you can either call a mean or an average. But again, this is going to have this same unit, kilopascals per second. But here is where what you're going to look at or what you're going to graph is you probably aren't going to do a standard deviation, especially if you had 2 data points. But what probably makes sense here is on your graph, plotting the mean, right? So for my percentages, and I forget exactly what I had here, but so I had 0.5, 1.5, I'm just going to try to guess here, 0.5, 1.5, I think I had 2.5, 5, and 10. And then I'm just going to write down, again, I forget which one I was looking at, but this was, I think, 0.021. So as you're putting in your slopes, you want to be really consistent about decimal places. So in this case, all of my measurements should have 3 if I've determined that this is my uncertain digit. And then also your mean. So you want your average to also have the same number of decimal places. If we had standard deviation, we might put that in here. But what we are going to do is, and let me just maybe put in these here. So I've got 0.041 and 0.035. Right, and then here's my easy way to calculate average of these. And so here you want to, and you can do this at all the same time. You can adjust this down to same number of decimal places. And so this is what I would plot on my graph, right? So usually your independent variable, yeah, we can also make this look a little nicer, but, and then these, I want to merge. So you can kind of play around with this. The really nice thing is as you're typing your report, you probably want to copy this and paste it in. I'm actually not going to pretend this is my report for a second. If you paste it in, you probably want to link to your spreadsheet. So format your spreadsheet in a sheet. And then what happens is if you ever change the spreadsheet, you can just update it on your Google Doc. But I'm not actually going to put that in right now. Okay, so then the next thing, and then there's another video, so I'm not going to do this here, but trying to put in your, right, so independent variable makes sense to put on the x-axis, plot your average, but then if you have fewer than 5 measurements, you want your, so we're going to say that you will plot your error bars should be the range. So you're going to have your average up until the highest value that you've measured. So that upper error bar would go all the way up to 0.041 from this mean or from this average. And then you want the lower error bar to be the lowest data point. So to plot this, it's probably going to be easier in Excel, or what I put up for you guys is a tutorial for OpenOffice, which is free if you don't have Excel. And so you might even want to do something, like what's my upper error bar and what's my lower error bar. And you don't have to put this column in your report, but you might just want to say, what's the distance from my mean to, actually the upper error bar is going to be the highest data point